Hello, everyone. Thanks so much for joining us today. My name is Bonnie, and I lead product marketing at Vespa. And I'm joined by Zohar, who is our lead solution architect. Now, today we'll be talking about how to solve the zero results problem in e-commerce. This is the first of a series of webinars. So if you haven't registered for the full series, be sure to check that out in the resources tab on the right side of your screen. Now, before we get started, a few housekeeping notes. This session is being recorded, and you will get a copy of the recording and the slides within 48 hours after the webinar ends. We'd love to get your thoughts and questions, so you'll see a Q&A option on the right side of your screen as well. Drop your questions here, and we'll address these at the end of the session. With that, let's go ahead and get started. Now, today I'll do a quick overview of the zero results problem. Zohar will talk through ways that you can solve that problem, and then we'll do a quick demo of the Vespa solution and the e-commerce experience there. And of course, at the end, we've reserved some time to answer questions, so don't forget to drop your questions in that tab on the right side of your screen. All right, so let's start with something every one of us has experienced as a shopper. You type in exactly what you're looking for, and you're met with nothing. No products, no guidance, just a dead end. And that's what we mean by the zero results problem. The customer query returns no items, even though the catalog does contain things that could be relevant. And this hurts on multiple levels. From the user's perspective, it's frustrating. It breaks trust. The shopper feels like this store doesn't understand me, and they often leave and, possibly to a competitor. From the seller's perspective, it's just as painful. Zero results mean missed revenue, stranded inventory, and lost opportunities to connect demand with supply. Now, the key nuance here, and this matters for everything that follows, is that this isn't just a buyer problem or a seller problem. It's a shared relevance problem where both sides have equally critical needs that the system has to balance. So let's talk about why zero results happen so often. Well, modern shoppers don't search in simple terms anymore. They come in with very specific intent. They're looking for particular shapes, colors, styles, brands, sizes. They filter by technical specs, compatibility, price ranges, and availability. And of course, they expect personalization. They don't want a generic list. They want results that feel like they were chosen for them. And this is where traditional keyword matching breaks down. If the system only understands exact strings or treats filters as hard constraints, it's incredibly easy to overconstrain a query and end up with nothing. But the shopper didn't mean show me nothing. They meant show me the closest, most relevant alternatives that respect my intent. Of course, relevance doesn't stop with the buyer. Merchants also have their own set of priorities that are just as real and just as dynamic. They need to balance stock levels, pricing strategies, and promotions. They may want to push certain items for business reasons, clearing excess inventory, promoting a current collection before a new launch, or spotlighting high margin products. And then there are external drivers no one can ignore: seasonality, cultural moments, weather shifts, even regional trends. The challenge is that many commerce systems force a trade off. You either optimize strictly for buyer intent or you override relevance with merchandising rules. In reality, the best outcomes happen when the system can blend both without hacks, manual overrides, or fragile pipelines. So now I'm going to hand it over to Zohar to talk a little bit more about solving the zero results problem. Zohar?
Thank you, Bonnie. So now let's double click on why the zero result problem happened in the first place. And you may be familiar with, some of the challenges. First of all, shoppers don't speak in catalog language. So your search system might have indexed an item as athletic performance running footwear, but customers are actually searching for running shoes. So traditional keyword first search system depends on exact or near exact term overlap, and any mismatch between how products are indexed and how users are searching could eventually create either non-relevant result or zero result event. Secondly, keyword fix don't scale. I mean, you can add synonym rules like sneakers equal trainers, hoodie equal sweatshirt, But this can quickly become unmanageable. As query volume, language variation, and catalog size grow, manual rules fall behind, and long tail query inevitably will break through the cracks. And finally, filters and constraint can eliminate result through overly rigid combination, or might actually end up in non-relevant result. So as a shopper searches then applies for a brand's size, color, and filter combination, they can suddenly end up with either zero result or non-relevant result. This happens because the combination of filters become too restrictive, like items that partially match user intent are excluded entirely instead of being degraded gracefully. For example, they could be ranked lower or surfaced as near match. And as this hard constraint stack, the system will end up returning non-relevant results. Uh, Next slide. In a traditional setup, what we find with our e-commerce customer is that they have separate components. They have a search query processing component, they have a product recommender system, and they have a re-ranker. And each one of them is operating kind of independently, passing data to each other. Um, this siloed architecture creates real problem. When you take, for example, ranking, when it's separate from retrieval, you cannot incorporate real-time signals like user preference, click history, or current browsing session context. You are ranking based on static scores computed earlier, not what's actually happening right now. The same goes for business rules. So if you have some business rules that you'd like to apply in real time, like the actual inventory level, and you want to boost a product that have excess inventory, it becomes quite difficult to coordinate between three different systems which are isolated from each other. Next slide. So now let's talk about Vespa. First of all, Vespa is one unified engine combining retrieval, ranking, and serving in real time. Let's discuss a little bit what this enables. First of all, it enables unified retrieval. Unified retrieval means semantic search, lexical search, and structure filtering all happening in a single query pipeline. In practice, this means that you could have a user that can do an image search for an item that they're looking for. You can combine that with the user context in terms of items that they've clicked on the website and their browsing history, along with the query search term on which you can do a semantic and lexical search, all in one pass. Secondly, Vespa is capable of doing real-time ranking on incorporating all real-time signals, like we discussed, just inventory in real time or the user context. And with Vespa, you can go beyond simple similarity search of dot product that you can do with your typical vector database. You can write your own ranking expression. And the ranking expression can also do a machine learning inference, such as, for example, applying in real time a propensity to buy model based on all these signals. Finally, Vespa is a production grade scale. Vespa can handle billions of documents and hundreds of thousands of queries per second with millisecond response time. Next slide. Let's now double click on tensors. So what are tensors? Tensors in Vespa are numerical structure. Think about your vectors in your vector database, which can be a single embedding. With Vespa, tensors are essentially sparse. So think about key value pair. They can be a dense representation, like the example of a vector of an embedding. And you can have map of vectors, map of tensors. And what tensors really unlock is the ability to represent complex data modalities. So we are just discussing how to represent a user context in terms of the browsing history, the preference of items based on items that they've clicked during their journey on the website, or the buyer, the business objectives. All of those business rules could be represented through these tensors. Secondly, on top of these tensors, which are can represent complex data modality, you can do complex math, right? So tensor operations, which can, for example, combine a seller's objectives along with all the buying signals coming from that user context, and be able to surface in real time the most likely item that this user will actually purchase. Ranking can incorporate as well, complex ranking expression that we just discussed, or even apply machine learning. So this really unlocks a lot of possibility when it comes to e-commerce and addressing the zero result problem. And Bonnie is going to discuss this more in the next section. Thank you.
Thank you, Zohar. And if you have any questions about tensors, again, drop questions in the Q&A portion of the screen. We also have some resources available to share more details about that, so be sure to check those out as well. Now, with Vespa, with the unified retrieval and ranking and model inference, you do get live blending of business and buyer objectives. So this really enables you to promote those soon to be obsolete inventory and searches, adapt to those weather aware product surfacing, even cultural driven boosts, and really being able to dynamically influence the results without sacrificing the user intent. One of the things that Zohar mentioned was Vespa being real time. And a lot of times when we look at other solutions, real time isn't truly real time. You have to do some re-indexing or rebuilding. And for us, for Vespa, real time is truly real time. You don't have to worry about batch jobs or overnight processing. As soon as things are updated, they're immediately available in the system, but they're also available for the end users who are searching for whatever that may be. And this really enables that continuous A/B testing because you're getting that immediate data on what's working. Now, the power of model inference in search, again, you're really able to deploy ranking models right within that serving layer so that you can get the real click and conversion data for your tuning. The system is really flexible, and the inference happens where the data is located. So this really does outperform the stateless, hard-coded relevance approaches that you see in other systems. And, if we were to sum it up, what you gain with Vespa, I mean, you get that seamless user experience. You get the fewer results and the fewer zero results and the greater satisfaction. You get seller agility. So it's that market driven campaign changes in minutes. And then, of course, business growth with inventory optimization and dynamic promotions. Now, so we can show better than we can tell, we'd like to go ahead and share a short demo so that you can see what a solution like this looks like.
Okay, thank you, Bonnie. So without further ado, let's jump into the demo. In this demo, you will see how Vespa powers advanced product discovery and real-time personalization and business-aligned ranking in one integrated system. And in this demo, we chose e-commerce on apparel because apparel presents a significant retrieval challenge due to the sheer number of product nuances, right? Like feature like material, fit, cut, and style. And how do you match what you have in store with exactly what a user is looking for? Let's take a look at what this looks like. So, for example, let's pick up this t-shirt. When I click here, I see a bunch of attributes that you may be used to see, like the title, the description, some additional, numerical attributes such as the price, the stock quantity, the review, which can be used for structured filtering during retrieval. But also, I guess one difference with Vespa is that the stock quantity can be updated in real time so that you are able to filter out items that are getting dangerously low in score. But you are also able to use that attribute value in real time during ranking, right? So let's say it's a Black Friday promotion or some promotion day. You may want to surface higher items that are not moving versus the ones that are flying off the shelf. As I scroll down here, you may notice this JSON key value pair. This is exactly what a Vespa sparse tensor is. So when you look at it, you have a bunch of attributes like a yellow color with a score of 5, navy blue with a score of 4. And this sparse tensor was actually generated during data engineering. So prior to indexing into Vespa, we used VLM on the picture of the item to be able to generate this tensor on the fly. We can now leverage it during ranking in real time in order to um, cross product attribute versus user preferences. Okay, now let's take a look at what the shopper experience is, right? So when I click on details, I see here the price of an item, the description, etc. And at the bottom, I see a bunch of similar items. So, these are all t shirts. They also have some yellow. They're printed. They have the same neck style. They're all short sleeves. And guess what? Yes, these were actually computed based on similar tensors. It's probably a dot product done between the sparse tensor representing the original item I clicked on and the rest of the item to surface the one that are closer. Let's take a look at, for example, at this pair of heels. So when I click here on details, same idea. I see here a bunch of similar heels, or they have some sort of a common attribute. For example, those are golden. These are similar heels, but they are silver, but they also have some golden on it, right? That's probably why they're being surfaced here. Now, let's take a look at what the personalization looks like. When I go here in my profile, I could actually represent my user personalization features the same way as the product features as a sparse tensor. And let's say I have a very strong preference for floral, and let's say I give it a value of 10. Let's save this. This might have been captured, from my previous browsing experience. I'll also show you how this can be updated in real time. Going back here, when I click on a personalized browsing experience, all of a sudden you notice that all the items that are being shown have some sort of a floral design, right? Now, when I click on details here, I also see in the list of recommendation, these items not only match the similar item that is here, but they also are tailored based on my personalization features. Uh, let's take a look at what this looks like from a search experience. So let's say that I'm looking for a pair of flip flops. Okay. So as you can see here, I see a bunch of flip flops in some random order by default, right? So the default is using lexical search. I can also in real time update the ranking method to semantic, um, and I get a different assortment. But what I'm mostly interested in is personalization, right? So as soon as I use personalization, I see that I'm surfacing first all the flip flops that have some sort of a floral design. Here, this has a bunch of flowers. This has flowers, etc. Right? So immediately I'm able to personalize the search on flip flops while still reflecting my preferences for a particular type of items. Now, going back to my profile, let's edit this profile and remove any personalization. Okay. Going back to square one, personalized, non-personalized, nothing changes because it's kind of the system doesn't know anything about me. But as I start, let's say at the beginning, this T-shirt caught very much my eye. I like it. I also actually, let's make this personalized. So as you can see, as soon as I click on personalized, the system has some click data on me that, oh, this was the item that I clicked. So let's say, oh yeah, I actually like this one. uh, I do like maybe this one as well. And as I click through in real time, the type of items that I'm being offered is changing. So this is real time personalization. How does Vespa make it happen? When I go back to my profile and let's take a look here, as you notice, I have a bunch more personalization feature. This in Vespa is actually represented as a sparse tensor. And each time I click on an item, if the attributes is not present, I'm going to add it with a initial value representing the value that the item had. It's averaged out. But if for example I click on two yellow item, then that value gets aggregated more, and at the end I get a very fine grained representation of my preferences in terms of users, right? So what happens now behind the scene is that I'm able, when I do a search, when I go on the web page and I get some content item recommendation, I can leverage all this information to surface in real time items that I'm the most, I will have the most propensity to buy. Uh, yeah, so going back to our main screen, click back here. I have my, you know, the system doesn't know anything about me. And as I navigate, the system, kind of provides me item that I like. As you can see, there's a lot of yellow because I clicked a lot on the yellow. All right. So I hope this was useful in demonstrating one particular concept about Vespa in terms of how tensors allows to represent very nuanced level of information and allows you to represent very accurate results, um, and surface items that are the most relevant to what a user is looking for. Thank you for attending this demo.
Now, the zero results problem is real and it's damaging, but it's absolutely solvable. The core issue isn't missing data, it's missing flexibility and intelligence in how relevance is computed. And this is where Vespa is fundamentally different. Vespa's all in one real time architecture lets you combine semantic understanding, structured filtering, personalization, and business logic in a single retrieval and ranking pipeline. This means you don't have to choose between the buyer and the seller. Shoppers get a personalized, intent aware experience, even when their query is imperfect. Merchants get control over outcomes that align with inventory, promotions, and real world business needs. When zero results disappear, both sides win, and relevance becomes a growth lever, not a liability. Now, with that, we would love to take some questions. We do have a couple in the Q&A ready to go, but if you haven't asked your question yet, there's still time. So go ahead and drop your questions in now. So this one is related to tensors. So the question is about the tensor, and is it based in the image or the text? So Zohar, why don't you go ahead and take this one?
Sure. This is actually a great question. So I actually said it during the demo. The way this happens, the tensor is actually generated on the image. So what we did during the data engineering process, we used the vision language model and prompted it to recognize, attributes of the picture, uh, given a set of attributes and some guidance into, what would be the possible range of attributes, and that essentially gave us the that tensor, which is a key value pair, right?
Awesome. Okay, we'll go ahead and show another question here. Can Vespa be used um, in the sponsored offers retrieval and integrate with other scoring models in house or ads auction modules? Mm, maximize that question for you.
Yeah, that is a great question as well. So yes, Vespa is really well suited for sponsored offer retrieval. We demonstrated here, the reason we are well suited to do that is given of our advanced ranking capabilities and the ability and business rules, right? So that will allow you to surface higher and rank better items that you wanna push up further, right? um, I should mention that one of the largest digital ad space player on the internet is actually running their entire sponsored content serving using Vespa. You might have noticed when you go to website like Yahoo or any major portal for news, when you scroll at the bottom you will see a bunch of sponsorized content, and the company running it is running this workload on Vespa using real-time signals from both click content and user browsing history, click behavior, to be able to adjudicate in real time what content should be offered at the bottom. And that's a very large workload running in billions of queries per year.
Great. Now, the next question is, how does your approach differ to other leucine based solutions? And with this one, I can go ahead and start, and Zohar, you can add on if you'd like. But one key thing is that Vespa is designed to avoid the heavy re-indexing and scaling limitations that's often seen in leucine-based systems. But one of the key differences is Vespa's advanced ranking capabilities. So you're able to blend the business logic and the traditional search relevance into a single ranking system, and it does that using a lot or a logical data architecture, a logical vertical data architecture instead of traditional sharding. So that really does enable Vespa to support large scale vector search using that memory node efficiently. But Zohar, I'm sure you can share a little bit more on that.
Yeah, I think you summarized it well, right? So I think the main difference is, you know, the Lucene approach. All the Lucene-based engine were traditionally, search lexical search engine, and Vespa from the ground up was built in as a hybrid retrieval engine. Vespa had Tensor's framework since 2014 in the product. So that's not like something new for us. It's not bolted onto the architecture. And it can very well show in our function and feature set, right? The way you are able naturally to write ranking expression across lexical signals and semantics, signals, which are just beyond cosine similarity search. You can essentially do any tensor operation, like we just demonstrated here, a dot product between sparse tensor. These things are very unique to an engine like Vespa.
Great. Right. The next question. Give me some examples for why stage ranking matters in vector search.
Yeah,
Go ahead.
that is a great question, right? So think of multi-stage ranking as having the ability to stage your ranking in multiple phases by with the first phase essentially giving you the ability to take a very large data set and apply a cheaper way uh, uh, qualifying your candidate set during match, right? So let's say you're in a situation where you have billions of vectors. When you have billions of vectors, for example, obviously it's not going to work to store all of those in memory, and computation is expensive doing similarity scale at this stage. So what you can do, for example, with Vespa, you can Vespa supports natively things like bit quantization. So you could do a Hamming distance in the first phase across billions of vectors, into the bitwise representation. And once you've done that in the second phase, you can actually um, convert these bits into a lossy float and do a dot product or cosine against your query vector embedding in float. That will still give you, a very good level of accuracy. You will only lose some benchmark. Independent benchmark have demonstrated that you might lose, up to 5 to 10% in accuracy doing this, but you will save, actually, compared to full float resolution, 32 times the memory footprint it requires to store them, right? So for second phase could be more sorry, could be more expensive computationally, but on a lesser set of vector.
Great. Thank you. All right. So I'll go ahead and move on to the next question, which is about the difference between what was shown here and other vector database solutions. So I'll go ahead and kind of share a little bit, and then, Zohar can expand. But I think the main thing here is, as we shared about Lucene engines, where they started with lexical search, you see vector databases that started with semantic. And so the key difference with Vespa is it really is a full platform. So it's not you don't need the separate systems for lexical search, ranking, or inference. It combines that traditional lexical with the vector search, the ranking framework, the model inference, and the extensibility. So, really, everything that you need as a foundation for your search and recommendation solution. So this really does, because it's in one platform, that really does reduce the system complexity and the latency. Anything you want to add to that, Zohar?
One thing perhaps I would add, Bonnie, so you covered it really well. The one additional, couple of additional point is that differentiates us is that tensor framework, right? Like vector data, like Colbert type vectors, multi-vector, we support that, natively. So when this Colbert vector came, a couple of years back, um, any of the existing vector database on the market could support that immediately. For Vespa, we've had the tensor framework, for more than a decade at that point. And for us, our customers were able to leverage that immediately and be able to start, ranking and doing tensors operations based on this Colbert model. And we can do way beyond simple, cosine similarity search that your typical vector database will allow you to do. We have a range of all kind of tensors operation that you can apply on top of this vector. The other aspect is the performance, right? So Vespa is really a large-scale platform which can handle, billions of vectors, like, and able to index them, able to do retrieval on them on milliseconds.
Awesome. And as a reminder, if you haven't looked at the resources tab, we do have a couple of links in there. One of those does include a little bit more information about tensors. Okay, the next question: what volume of offers and products can you support? Now, I know we do support billion scale, but I don't know if you want to expand on that a little bit more.
Yeah, so I think we kind of have addressed this already, right? Like, yeah, we can support very large store when it comes to e-commerce or ad use cases. Our use cases have proven by our customer usage that we can store billions of items and product and maintain a response time of milliseconds. Obviously, this requires certain optimization that are part of the core platform, right? Like I just explained, multi-stage ranking, right, is one way to keep the performance at this scale without sacrificing the accuracy. There are certain techniques like bit quantization, the ability to page vectors to disk to be used for a second phase ranking. So a lot of the optimization techniques that Vespa provides, as well as the scalability and the patterns of how you are able to distribute the data and build a cluster topology using a pattern on infinite scalability also help us, right? So Vespa was really designed for from the ground up as a large scale, platform back in, for Yahoo back in, 15 years ago.
Awesome. Okay, we do have a couple more questions. So if you have any last minute questions, we do have a couple minutes for you to add that on here. But we'll go ahead and move to the next one. So this one's really about any. Can you name any metrics improvements after Vespa implementation? So yeah, I mean, we do see a lot of improvements with our customers, double-digit improvements in conversion rate, average page views, category and catalog views. We do have a couple of case studies available on our website if you want to take a look at those. But yeah, we definitely have seen some metrics, some improvements in those metrics. I don't know if you want to expand on that anymore.
Yes, Puni. So yeah, you are right. Some e-commerce customers have improved double-digit improvement in conversion ratio, and some of them was directly attributable to what we demonstrated here with real-time personalization. So they think works and it's kind of proven. We're happy to engage in further conversation if you are interested in discussing these use cases.
Great. And I believe that was our last question. So I do want to thank you, Zohar, for joining today. And thank you, everyone else, for joining. We appreciate you spending these last 40 minutes with us. And as a reminder, this is a series that we will be holding monthly on various topics in e commerce. So thank you so much.
Thank you, Bonnie. Thank you all.